Welcome to today's institute lecture. And in order to welcome the guest, I request our director to hand over the bouquet to Professor Srinivasan Parthiban. So I'm happy to introduce Dr. Srinivasan, who is founder and CEO of Vingyani, a data science company focusing on Informatics 2.0, that is AI for drug discovery and health. Dr. Srinivasan is an experienced data scientist who has earned his PhD from Indian Institute of Science, specializing in computational chemistry. He holds dual master degree, one in science and the other one in engineering. After his PhD, he continued the research at NASA Ames Research Center at USA, and thereafter at Weizmann Institute of Science in Israel. Then he worked at AstraZeneca in the area of computer-aided drug design. And prior to founding Vingyani, he also headed Informatics business unit in Jubilant Biases, GVK Bio, as well as in reverse informatics. So with this, I welcome Dr. Srinivasan to deliver today's institute lecture.
Good afternoon. Thank you very much for the kind introduction. My name is Parthiban. At the outset, I would like to thank Professor Umapati for inviting me to this beautiful campus. Actually, it's much bigger than what I actually visualized about IASER. So it's terrific. Thank you very much again for inviting me. And also, I would like to thank Kushal and Sanjeev for coordinating all this meeting. And thank you very much. Great. So the title of my today's talk is on data science and artificial intelligence, transforming science and improving lives. In the last couple of years, if you have seen any of the major newspapers or news articles, journals, and things like that, the AI topic would be there. Of late, the media has attracted the attention of this term, artificial intelligence. So when I was a student way back in the early 90s, essentially the amount of digital information, the percentage of digital information by which we store and communicate the digital information is less than 10%, probably 5%. But then the year 2002, that's when it marked 50% of the global information became digital. So that's the year we can say that the birth of data, big data. But then again, year till 2008, there was not a term, the data science or data scientist was coined. But that's when year 2008, when people started talking about the data science and data scientists, and even the Harvard Business Review started talking about the 21st century, data scientist is the most sexiest job. And then from then, the whole hype gone up until year 2014. But at the end of the day, data is just a data. It's a dead data. But the hype was too much in the years 2010, 2011, and it has promised so much, but it did not deliver what it has promised. But then gradually something swept in. That's artificial intelligence. The year 2016 is the biggest year for artificial intelligence. That's when the whole world woke up. Hey, something else has come on. The big data has really found its match in artificial intelligence. So in this talk, I'm going to focus on how this data science and AI together, which is transforming science and making our lives better. And before getting into this, I'm sure most of you know that who he is, the Johannes Kepler and Tycho Brahe. Tycho Brahe, for 40 years, he was observing the astronomical stars and all that. He was very meticulously, he was taking the data out of all the observations. But then he does not want to give the data to anybody, but with a lot of struggle, Kepler joined him as an assistant. He is an intelligent mathematician. So when he joined together, so even after, Tycho Brahe, he was thinking that the sun and the moon, they are revolving around the earth, whereas the rest of them, everything revolving around the sun. But after he died, Kepler convinced Tycho Brahe's family to get the data, and then he analyzed, and that's how the Kepler's laws of planetary motion, the 3 famous laws born. So imagine today the big data without artificial intelligence is Tycho Brahe without Kepler. So they are the first data scientists and the first, in the modern language, the first AI guys. And so what is the data science then? So this is kind of a self-explanatory picture which tells you what data science can do. Even, for instance, from a data science perspective, if you look at Copernicus, the person who gave the heliocentric theory, Darwin, evolution theory. So from a data science perspective, they are not really a discovery of a new theory. It is a fertile new point of view. So the data, when you have a data gives you the insight. When you have so much of data, it gives you a completely new knowledge. So the data science is the one which facilitate the knowledge which is in the unstructured format to give a structured format. So this is what the data, so that's why, so define data science, if you look at the 10 different books, you will find 10 different definitions. There is still no consensus picture on what is the data science. So simply we can say that data science is the discipline of making data useful. So to give you the picture, so typically in a lab, a scientist, a researcher, ask a question. First they ask a question, based on the question they do the experiment, collect the data, and then find the answer for the question. So let's assume that's the granulated data and the knowledge. So you can say that from the purpose of informatics is to gain the knowledge from the data. So here you can see the data which is converted into knowledge through informatics. But again, knowledge is unstructured, data is structured. Then you need to have another mechanism by which you have to extract the data back. That's what I call that as a reverse informatics. From data to knowledge is informatics. From knowledge to data is a reverse informatics process. But if you have multiple articles, let's say from a journal or multiple sources of information, that's what we call as a big data. But again, with the big data, what do? You create synthetic knowledge. How do I generate a new knowledge with the existing set of data? I can tell you one example, Swanson. He was a librarian. At the end of the day, his job is to keep the book back in the rack. So first week he was reading something about in the book that is our fingers. There is something called Raynaud syndrome. Raynaud syndrome is our fingers get discolored. That's one of the Raynaud syndrome. And the next week, he was studying, he's a librarian. He was just trying to keep the books back in the rack. He studied something like fish oil could resolve this issue. So in a way, change the viscosity of the blood. He just connected these two dots. And then today we have a FDA approved drug, which is the fish oil could treat the Raynaud syndrome. He didn't do any single experiment, just connecting the dots. So the message is, humans have discovered the solutions for most of our pressing problems. But the challenge is these solutions comes in the form of puzzle pieces. A patent document here, a journal article over there, a Chinese document, online heated discussions over there. The whole knowledge is scattered. The abundance of knowledge that we have today is unprecedented. But the thing is, our human brain does not have a sufficient computational power to process them all. To say easily, we cannot read all these articles. In a given day, in a given technology and medicine, at least 5,000 articles are getting published. Forget about the millions of articles already which has been published. So we cannot read 5,000 articles a day. Now, what happens to these articles? Most of them, at the end of the day, it ends up as a digital dust. The statistics is that 50% of these articles are not even read by 5 people. Imagine if we have a big brain which can read all these articles, connect these dots and make sense. This is the purpose of data science that we are talking about. That's the reason we are talking all these today. And you all know that the life sciences people, they know the central dogma in molecular biology. The information flows from DNA to RNA, which is a transcription, and then the translation, the information goes from RNA to protein. Whereas in the informatics, data information and knowledge. The term bioinformatics was coined in 1978, and then for equivalently in chemistry, cheminformatics was coined by Frank Brown in 1998, and then 2008, which I coined this reverse informatics, because what in India actually we are trying to do is not we are going from data to information to knowledge, we are actually going from knowledge to information to data. In fact, that's what I call is we are kidding. Actually, informatics in reverse. This was an interview which came in the bio IT. So the whole process of this whole data sciences, let's imagine the whole researchers who are working in the oncology, the cancer. One of the important biological target is kinases. And all the researchers in the life sciences department or in the pharma industry, they are all working towards finding a small molecule which can arrest those, the aberrant cancer target so that we can find a cure for cancer. And every day people are publishing journal articles. So convert those journal articles into granulated fashion, put it back into the database. So when you have millions of molecules in this database format, I can retrieve the compounds in a click of a button. I need the basic chemistry scaffold of this with the particular kinase target. It could be mTOR or MAP kinase or any of those particular kinase or kinase, GPCR, ion channel, nuclear receptors, any particular biological target. I need this particular scaffold having a biological activity less than 1 micromolar. Click of a button, I should get all these molecules, whether it is filed a patent by Pfizer or published by IISc or Bhopal, it doesn't matter for me, the bibliographic information. All I need is a particular scaffold with the biological activity data. Click of a button, for the last 20 years I need to get it. So this is what the data science that facilitates the researchers to go forward. So in a summary, for a data scientist, to be a data scientist, what should I have as a position of the skill set? First, start with the domain expertise. Whether you are in the financial market or in the manufacturing industries or a pharma industry or retail industry or entertainment industry, the domain knowledge is the most important stuff. Second, data ethics and regulation. You should know just because the data is available in a particular website doesn't mean that you can just develop a web scraping and then go and pull out the data. There's a lot of ethical issues which are there, and then licensing issues. You should know about before collecting those data. You should know about the ethics and regulatory stuff. And data wrangling and databases. Most of the companies, they have in-house data. But apart from their in-house data, and apart from the lab which creates its own data, you collect data from multiple places. That's where you need to do the data wrangling or data munging and those kind of stuff. And of course, the computer science and the high performance computers, so you need to run those things in the cloud, and data visualization, statistics and probability, machine learning, and communications. Just because you have done a beautiful science doesn't mean that you have done an excellent work. It needs to be communicated to your colleagues, and then your ideas should be implemented. So the entire skill set, this is the skill set anybody who wants to aspire into data science. So what is the language for data science? Of course, 10 years ago, nobody heard, most of the people, they have not heard about something called Python. Everybody was working on either, Ruby on Rails or traditional Fortran programming, or the statisticians, they use only on R. But you can see that the impact of data science in the last couple of years or the last 3 years, kind of a Python is going up above Java, JavaScript, and Python. And also one of the reasons why Python is becoming more powerful is it's not just because of its Python, but the library which comes along with that, like NumPy, Matplotlib, and Pandas. The tasks that I said in my previous slide, these are the languages that you need to master, and this gives the entire ecosystem for a data scientist to be called themselves as a data scientist. So, but again, the ecosystem is so vast, where should I start? You need to understand one thing. In the whole entire gamut, the artificial intelligence or machine learning is just less than 20% of the component. The rest of the time that you will be handling with the data, whether loading the data or cleaning the data, and extraction, normalization, deduplication, and a lot of data, missing data, and automation wherever possible, building a guidelines and control vocabulary. So that constitute your 80% of the whole time. So this is what the entire data science which talks about. So one of the reasons why I'm emphasizing on this big data is, like way back in 2015 when Obama was the president, his vice president Joe Biden, his son passed away in 2015 because of the brain cancer. So he was wondering, so we are the world's leading country in the medical research. In the past 30 years, they have invested about $1.8 trillion in life sciences in the cancer research, but still the leading doctors could not save his son. So he consulted most of the oncology scientists, and then one thing they said is, they are not able to comprehend the data which is generated by this oncology research. Then he realized the solution for cancer research can come from big data guys, not necessarily from the life science researchers. So then he launched this cancer moonshot program. Immediately they approved a $1.6 billion. And imagine National Organ Labs in Chicago, they are not a life sciences organization, but today they are completely into the cancer research. So the big data got a big boost in 2016 from Joe Biden, the vice president. And 2016, towards the end, in 90s, Bill Clinton was credited for a lot of software boom and things like that. But actually, we are really for this AI boom, current boom, Obama should be credited. He was the first one to think about a national policy for AI. But then, unfortunately, in 2017, he was not the president. Trump is the opposite party, so he did not carry forward what the Obama's vision was. In 2016, he has edited a magazine on Wired, and then he was talking about the artificial intelligence and how this is going to benefit the humankind. He was talking about it. But then Trump initially, he wasn't interested in taking this forward. But then Canada came up with the first national policy on AI, and then a couple of other countries followed. But then when China came up with the first national comprehensive policy on AI, that's when Trump woken up. And then US came up with their national policy. Now they have allocated about $3 billion for the next 5 years exclusively for this AI. So this is the story of whole thing. So when I say 2016, 17 and all this stuff, the AI is not something new. And most of you who are already glancing through various articles, you are pretty familiar on this. The birth of AI, like the first AI term was coined in 1956 from Jim McCarthy, the perceptron, all those, the neural concepts which came in around 1950s. And then 1974, today we are talking about the natural language processing, right? The basic building blocks for that is the recurrent neural network. So that concept which came in the year around 1974, there again there was a huge hype. And then there was the whole concept of AI. It has promised so much, but it delivered nothing. So all the funding overnight, it got cut off. And then it all came down. And then again it came up in the 80s. And that's when we are all talking about the computer vision, right? So the convolutional neural network. So that's the concept which was generated during the second hype. But then in the early 90s, even actually in Bangalore, we created what is called the CAIR, Center for Artificial Intelligence and Robotics. So assuming that the government brought Professor Vidyasagar also. So meaning we thought that the AI is going to take off in the 90s. But then the internet came in and the software boom which happened, the rest is history. Probably most of you know that. So that's called AI winter. But again, this whole explosive growth, I consider started in 2012. 2012, when the ImageNet competition, when the deep learning, which kind of created the history, and 2014, generative adversarial networks, which kind of created a generative models, and then 2016, Lee Sedol was defeated, the world's champion in Go game was defeated by AI, and 2018 BERT, the natural language processing. So these every 2 years we are seeing so phenomenal growth, the milestones within the last 6 years, there's so much of growth which has happened. That's the reason now we are seeing the explosive growth in AI. And why now? Because of the convergence of three factors. The computational facilities in terms of GPU, TPU, and then the cloud computing in terms of Google platform and Azure from Microsoft AWS, and models, the computational models. Now I don't need to build anything from scratch, whether I want to build a ResNet or any of the CNN or RNN or BERT, most of them are available online for free by a click of a button. And then the PyTorch, TensorFlow, these kind of open source frameworks are available for free. Just you do pip install TensorFlow, you get it. But way back when I was a student, we used to pay close to 100,000, equivalent to this. When I want to install in our institute, even the academic price in India, we used to pay like something around $100,000 to get something equivalent to what you are seeing as a PyTorch or a TensorFlow. And TensorFlow 2.0, which became a revolution in the when this was launched this year in 2019, the Keras and TensorFlow joined together, and the data. This is the biggest piece. The data now is available for free, and especially in the life sciences, for those who are involved in the small molecule drug discovery. It was never used to be available for public, never used to be available for researchers. It was only a closed domain for the pharma industries. And I remember we created millions of compounds and sold it for $1 million in 2004, based from India. We sold it for Pfizer. Now all those data are available for free, which means that you got millions of dollars worth data which is available for free for the researchers, and $100,000 worth of all the AI frameworks which are available for free. Even to begin with, the Google platform is, again, cloud is free for the new beginners. So this is the reason that we are seeing the explosion of this whole stuff. And then whenever we talk about innovation, we always touch upon Silicon Valley, right? So Silicon Valley has already seen 3 different waves. In 70s, semiconductors, 80s, the personal computers, and then the internet, which saw the Facebook, YouTube, LinkedIn, and the smartphones. There is no further investment is needed for smartphone. I think it has reached a saturation. I think 10 years ago, if we look at 100 people, all the 100 people were carrying a mobile with a different kind of sizes and all that. Now I think we reached some kind of a standardization. And the 4th wave is now the artificial intelligence. In the last couple of years, 2017 and 18, it's about several-fold increase in venture funding has come for AI. If you analyze 10 different business proposals, 9 of them were touching upon one or other aspects of deep learning. Even actually today, you go to nature.com, all the journal article, take the November month, look at all the journal articles published in the November. You would see quite a significant number of articles which talks about deep learning or artificial intelligence concepts. So when I say AI, the first thing comes to the mind of the people is something like a Terminator. So when I say, but you need to understand this is a strong AI. Current state-of-the-art technologies on AI is nowhere closer to strong AI. So what is meant by strong AI? Strong AI has a trait of self-awareness, self-consciousness. But the thing is, what we are talking as AI is weak AI, or you can call it as a narrow AI. So narrow AI is designed for a specific task, designed for doing particular tasks which will not be able to do the other tasks. So that's what is a weak AI, but we call them as a AI. So that's the reason when I say to the society, I'm working on artificial intelligence, people think that I'm working with some kind of a robotics. This is a Boston Dynamics stuff. And then when my friends think that, most of the guys who know who he is, Andrew Nag. So he's the guy who taught AI for millions of students across the world, the most popular guy. And people think that, my friends think that, oh, this guy is doing something crazy. And, because of this hype, people think that other computer scientists think that, oh, these guys are making so much of money and they are most of the time they're spending a party. And the mathematicians think that, okay, these guys are doing a lot of simulations work, but actually not really any mathematics kind of stuff. But actually what I think is essentially I just go and try to explore business possibilities within AI and data science. That's what I think. But actually finally I end up doing import Keras using TensorFlow as a backend. That's what I actually end up doing. The reason is, in software industry, normally you would see that MBA guys as a business development guys, they travel around and then they try to meet the customers, convince the customers, and then try to bring the business. Here they hire the technical guys. Whereas in AI, you put a garbage in, garbage out. It does not matter whether you feed some wrong data, still you will get the results. So basically your customer needs to talk to the actual technical guy. If a business development guy does not understand the technology behind the business, you probably may not get the business. That's the reason still in India, all the big guys like Infosys, Cognizant or TCS, they are still struggling to get the big business, mainly because of that. Because their business development front-end guys are MBA guys. You need to have a guy who can speak both business as well as the technology. So finally, I end up doing these things. So let's try to know this again. Still, the AI is there's so much of jargon: data science, artificial intelligence, pattern recognition, speech recognition, computer vision, object detection. Let's bust this. Let's try to understand what the hell is this. So let's kind of break this down into abilities, the human abilities. What are the human abilities, tasks, and methods? So basically, the top you see what the human can do. We can see, hear, listen, and write, and read, and planning decisions. So this is the AI language is computer vision, speech. There he is speaking and the other one is listening. So these are all the abilities. This is what we are trying to do the tasks. The tasks are nothing but the image classification, image identification, pattern recognition in the computer vision part, and then the speech to text transcription, and then to the sentiment analysis, document classification, machine translation, and then of course the self-driving cars and the robotic stuff. And whatever we say, expert systems, machine learning, deep learning, reinforcement learning, which are nothing but methods. When I was doing 5th standard, I didn't know should I do BSc degree after my college or should I do college after my BSc? That was my biggest confusion. So likewise, so here we need to understand when somebody says computer vision or somebody says the pattern recognition or the image identification, image detection, so you can classify them. When you have this framework in your mind, you can easily understand what the others are talking about. So let me put a small video here. So what's the current state of that?
Mr. President, what do you think about AI? It's a great thing to build a better world with artificial intelligence. Can you speak in Chinese? 人工智能正在改变世界.
Let me play one more time. So was it audible? Yeah. I don't know.
It's a great thing to build a better world with artificial intelligence. Can you speak in Chinese? 人工智能正在改变世界.
So essentially what is happening is all the Trump's past speeches were given as an input to the deep learning neural network. And in his own context, his answers were translated by the machine and in his own tone, it's written back. It's not really Trump has spoken on this. So this is today the state-of-the-art technology in terms of speech synthesis and natural language processing. So this is, I just wanted to give you as an example.
Mr. President.
And here, what this is. This is MasterCard. So the MasterCard, this is a credit card. So we think that MasterCard is a credit card company, but no, it is actually the main technology company. And I need to tell you that the different verticals like manufacturing industries, financial sector, pharma sector, and various telecommunication sector, financial sectors are front running in the application adopting to AI. Look at this MasterCard. There are 2.5 billion card holders, 23,000 financial institutions, 50 million merchants in 210 countries, 74 billion transactions. Every single transaction takes about 130 milliseconds. If any fraud happens, the system has to stop within that 130 millisecond. So what is happening right now is that currently it's about $24 billion, which is the company is losing because of the fraud. So in the next 3 years, it's going to be $34 billion, as a double-digit growth, and they need to stop it. How do they stop it? This is where they are investing heavily on artificial intelligence in terms of a fraud detection, and this is one of the big area of AI research currently going on. And the next one is AI for transportation. Of course, you would have heard about autonomous cars and various sizes. But the first thing which is coming to the market is the autonomous trucks, which is already 35 trucks, which are already in the roads in the Midwest. The company is 2. And then AWS, the Amazon is coming up with the food delivery. The other one, that is a food delivery, and this is a grocery delivery, which is already, they have a census, and the GPU machines are sitting at the backside of the same thing, and this is called edge computing. So currently the AI, this had some kind of a hiccup, but again, now it's again started picking up the AI for transportation industry. And another example is NASA and Google joined together to analyze the data coming from the external exosphere. So through this data, Google has, with the application of AI, identified the 8th planet in another solar system. So this is another application of AI, and currently the precision agriculture, the AI in agriculture is a big market, in the sense that all the developed countries already, they have increased their productivity to 600%. And also the rural young population, they are not too keen on getting into the farming. So given this, the AI is playing a role in a couple of ways. One is on the data analysis component. The second one is the agricultural robots. Here again, the data comes from the satellite, but because of the clouds, now some of the companies started using drones for collecting the data, so to yield better productivity and optimizing the water consumptions and so on. So we talked about Lee Sedol, right? In year 2016, he was defeated, but still again, he played with the computer 5 times. 5 times he was defeated by AI, 5th time he won. And he's the only guy in the world who won the computer. Maybe he would have been defeated by 4 times, but still he won once. But after that, none of the world champions or the world main guys, they could defeat AI. And that was through reinforcement learning. And in 2017, AlphaGo was developed as a 0, meaning the AlphaGo was in 2016, it learned it from the previous 100,000 games played by other people. Whereas here, it consumed the rules and it played against itself, and then finally it played against AlphaGo. So AlphaGo 0 versus AlphaGo, and AlphaGo 0 won all the time. And last week, Lee Sedol announced, I'm taking a retirement. I'm not going to play any more Go games because there is a new entity called AI, which I can never be able to defeat. So this is the power of AI right now, which is going on. So this is the news item. World champion Go player quits because AI has become too powerful. So the other area, so the same AlphaGo reinforcement learning developed by the company Google's DeepMind also last year made a big news in the protein structure formation, protein structure identification. So that's a big news. This is this week chemical engineering news. Now it's 2019, we are almost in December. So the 2019, the whole review process which happened, and in the chemical engineering news this week, if you read it, I just saw it today morning. So AI drug discovery came into its own. So AI was never a big component in pharma industry until probably till 2017. The last year only the pharma industry all of a sudden woke up, and then they realized they don't have a skill set in-house. The pharma industry, getting an appointment with the big pharma company is next to impossible. Only the top management consultancy can open the doors. So that's the reason companies, the startup companies or any of the corporates in India, they normally go and talk to the management consultancies. Through them, they go to the big pharma company. That's the usual practice. But now, the big pharma companies start inviting the small startup companies to come and present their capabilities, skill set, and what they can contribute to the designing the drug discovery molecules through artificial intelligence. Almost most of the pharma companies are hiring interns because the computer-aided drug design guys, overnight you cannot expect them to start writing a programs in TensorFlow or PyTorch or any of those AI languages, but the smart guys are in colleges. So that's the reason if you go to any of the AI meetings, you would see less than 30 years old guys will be predominant 80% of the people, but any of the other conference, you will find mostly 50 plus. But the AI conference and data science conference, wherever I go, I find 80% of the people are less than 30 years old. So this was not even a field last year. This is kind of mentioned by a professor from the University of Michigan. So this is this year. So here, this is where our company, we are also working on AI for drug design. We have chosen a molecular target of oncology, and we are developing the small molecule with the use of generative adversarial networks. We are building a platform that will dream for a compound for a given disease. So this is our objective of building the AI for drug discovery. That's one aspect. And this is the, okay, so you are familiar with the Facebook, right? So whatever that you are writing Facebook, your information goes to Sweden. So this is the Facebook data center. The bottom one is the Google's data center, because the US biggest concern was these two companies are consuming a lot of power, and they want them to kind of optimize their electricity consumption. So Facebook, they shifted their data center to Sweden, so which is in the Arctic Circle. So you don't need to put a AC over there. Whereas Google, they have built the AI platform which will optimize the operations. So this you know pretty well. So let me go a little one step further down. So what exactly at the end of the day AI or machine learning or deep learning? This is not for the experts who are sitting here, for the freshers who want to think freshly about it. So you know what it is, 3 plus 3 is, which is 6, yeah. But if I give you this stuff, now if I ask you 3 plus 3, will the answer be 6? Obviously, you will not say so. So what is happening here? I have given an example. You learn from the example, build a logic, and then you applied that logic on the new test case. This is exactly what is machine learning is doing. So the reason is, here if I give you, instead of the first set, second set, you will not put 33, you will say 30. Here it is 3 plus 1, which is about 7. So the reason, so here for different system, will you be constructing a different logic for each and every one of them? Will you be coding for each and every one of them? No. So we want a system to consume this data and then build its own logic. So that's the purpose of machine learning. So essentially machine learning is all about learning from data, that is from examples, build a logic and predict the output for the given input. So this is what we are trying to do. And again, to make it pretty simple, this is chicken curry. So this is the actual easy to understand the machine learning stuff. So if you want to make the chicken curry, first you need the ingredients, and then you also need a recipe for making that. And then when you are cooking, you need to understand, is it good or not? So you test it. So based on that, you provide a feedback. That's what is the learning. And then finally, you do the evaluation. So basically, when you talk about, so let's talk about each one of them. First, the data. So data, when we talk about data, there is a structured data and unstructured data. So when we are talking about the data, two things. We saw the MasterCard, credit card. So where you have a billions of users, whereas for every single record, you have an author name, I mean the credit card holder name, date of birth, and a card number, and some other additional details. So it may not be more than 10 or 15 columns for every single record. This is one type of a data. Whereas if you come to the science, especially the life sciences or small molecule chemistry, for every single molecule, you probably may not have a billions of compounds. You may have probably 10,000 compounds, but for every single compound, you will have 1,000 columns, 1,000 parameters, 1,000 descriptors, 1,000 properties. So you need to do a dimensionality reduction. So this is a second type of a data that we are handling in AI. This is each one of them have its own different challenges. And then the tasks. So let me skip over because so again, when you come to the model, there is a supervised and the unsupervised and the reinforcement learning. In supervised learning, essentially what we know goes as an input and what we want to know is an output, basically the labeled data. Essentially in the stock market, every Monday they try to predict what will be the stock prices on Tuesday. This is conventionally in the stock market they do it. The way it's done is The last 10 years, Monday stock prices, I know. Last 10 years, Tuesday stock prices, how it changes, I know. That's the data that I have. And yesterday was Monday, right? So, or today is a Monday, or yesterday was a Monday. So, normally, typically in the stock market, they try to predict what will be the stock prices, how it is going to change from the history. So, that is essentially called supervised learning. And the unsupervised learning is essentially you don't know anything about it. All you have is the data. Say, for instance, in pharma industry, when you are working on designing a new molecule, you have an option of 1 million compounds. But your project will allow you to synthesize probably 1,000 compounds. How will you synthesize select 1,000 compounds from million possibilities? One way to do is do a clustering. You don't know anything about those compounds. You just do the clustering. Pick one compound from each cluster. Whichever the compound which shows some promising property, then you try to close that particular cluster and then start making multiple choices out of that. So, these are all some of the ways by which the unsupervised learning is done. And then the third one is the reinforcement learning. Currently, this is the biggest buzz. Most of the video games are all based on this reinforcement learning, and now the reinforcement learning is also entering into every possible areas. Here, we are designing an agent. The concept is pretty simple. Let's say that I am an agent and you are the environment. So, I need to take certain decisions. Let's say my task is to get a best applause from you. What do I need to do? So, I need to give a better performance here. So, I get a rewards from you. So, if I don't perform well, I can say, when I see somebody who's glancing through the mobile and then try to talk to somebody, which means that I'm performing bad, which is you are punishing me by focusing on your mobile than listening to me. So, you are listening to me, which is a reward for me, whereas when you are looking at the mobile, so this is the policy which I am deciding. So, essentially the reinforcement learning is an agent designing a policy so that he gets a better rewards from the environment. So, this is the whole concept of reinforcement learning. So, these are the various models that we do it, and then these are all the various concepts which comes along with that. So, essentially the whole foundation of machine learning is based on probability, statistics, linear algebra, calculus, and then the 4 pillars are regression, classification, density estimation, dimensionality reduction. Let me take a little bit pause from here, what we also do apart from the science, because there's a lot to learn from the entertainment industry also. So, essentially you are learning from the data. So, the learning from the data is, let's say that YouTube videos. So, for example, I'll play this song. I'm sure you will find something different is going on. Can you make out something different here? What's the difference? You would not have seen this earlier if you have watched this song earlier. Color, exactly. This is colored by AI. This is done by us. So, what you have seen there is from YouTube videos, our AI algorithm goes and learns how the sky looks, how the tree looks, how the road looks, how the skin color should look. It all learns from thousands of videos from YouTube. Now, it applies to a black and white image, but also the most important is from one frame to next frame, when I move over, it has to maintain the same consistently, maintain the color. So, that's the stuff. So, when we find, some of the blue shades that you would find, that's the loss. So, the loss that we are trying to minimize it. So, whenever we find there is some kind of a bluish gray, that's the loss. So, the loss you need to give a feedback to them. Sometimes you will find the hands, so bluish, like Mahavishnu kind of a stuff, so which comes in. So, this can be avoided if I have a very high resolution video. So, in fact, I have a video channel, I have put a lot of videos from multiple languages on coloring this stuff. So, our objective is to make it really into a commercial mode. For instance, one of the challenges to bring in a higher resolution. When you have a low resolution video, we want to build a higher resolution video. Once I have a higher resolution black and white, the colors will be very good. And I don't know if you know about movie Maya Bazaar in Telugu. the 200 people who worked for 1 full year. It was a several crore project in way back in 2011. It was done completely manual. But the same work which I can do it in AI in about a month time if I have 4 or 5 people. The same 1 full movie, I can make it black and white in color if I have a very high resolution. So that's the technology. The technology that we are trying to use it for drug discovery, the same technology I can use it for training the neural networks to color the black and white images. So one big major breakthrough which happened in 2014. So can you predict which face is the fake? First or second? So probably you might be still thinking, actually both are fake. So essentially it learns from the noise and it starts generating the faces. And look at the technology. The 2014, when the generative adversarial network, which was first kind of published, so that's the state of the art technology, 2014. And then essentially the learning rate and the loss mechanisms, it's called the Goldberg-Leibler divergence mechanism. And then there is several variations of that has come in place, and then which has progressed to this extent today. And we can generate this stuff. So it all started in 2009. ImageNet competition. So identifying an object from the picture. So here until 2011 it was a shallow network. So deep learning was never used for visual data analysis. So until 2011 you can see that it was more than 25% error. But today it's reached less than 5% error. 5% error is the normal, any skilled human being create this error. So you can see that from 2010, 2011, it's above 25%. Then the error rate is coming, and 2015, it has surpassed the human level of this stuff. So this is the reason why today the medical diagnostics field in terms of pathology or radiology, in terms of interpreting given pathology sample photograph, is it a diseased one or disease-free one? So this is the reason why this particular field is progressing so advanced. Let me move on this stuff. So it's all based on how our brain works. So if you zoom in, you will find the billions of neurons, and how the neuron works exactly, that's the mathematically simulated. So this is the each neuron is simulated, and this is a fully connected layer, convolutional neural network and the reinforcement neural network. So this is the basic fundamental building blocks. And in principle, so how it works, it's such a simple programs that can identify character pattern recognition, character recognition. And this same technology, it's not only for the science, as I said, it's called style transfer. If you have a photograph, so the top one is a vanilla photograph, meaning it's not manipulated. The rest of the 3 photographs are based on the style which is in the smaller photograph is translated into that picture. So now, actually, when I was visiting Sweden, so I was trying to take a video out of that. So you can see that it's a style transferred video. Actually, I'm just standing over there. From another photograph, the styles in another photograph is translated into the original video. So actually, I asked those guys, why did you build this? They said, we don't have any application for this piece, just for the fun, for the sake of building it, we build it. I told them, this is $1 million worth in India, because in Bollywood, Hollywood, Kollywood, we have dream songs. We can make use of this, and this will, kind of save my building the, see, for instance, with the use of this, I can make this appear like gold, built in a palace kind of a stuff. With the use of style transfer, we can convert the whole stuff. So I find that this the entertainment industry will benefit a lot out of this AI. So this is another breakthrough which came this year. This is the person who knows the dance is at the top. And these 2 guys, they don't know anything about the dance. And I'm only taking the style from the person who knows the dance. The style is transferred onto the person who does not know the dance, which means essentially Michael Jackson dance can be translated into the Rajinikanth body. So this is what is feasible right now today in the artificial intelligence that we are currently working on it. So let me move on. I think time is pretty limited. What is happening in the natural language processing? And so let me just touch upon just one slide in drug design, and then maybe a couple of them. So you all know that what is Moore's law? Moore's law is that every single year or every 18 months the computational power is doubling. That's what is Moore's law. If you reverse the Moore, it's Irum. So this is called Irum's law. Is essentially if I give you $1 billion, how many drugs that you will be able to discover? Way back in 1950s and 60s, at that time, for $1 billion, you will be able to discover close to 100 drugs. And it's sort of the productivity came down, and during the year 2000, one drug costed $1 billion. But today, to discover one drug, it costs about $2.6 billion. And also imagine the pharma industry's risk. If I start a project today, it takes about 15 years. Let's say now we are in 2020. In 2035, the drug is going to come to the market. I don't know how the market is going to look like in the year 2035, but you are asking me to invest $2.6 billion and you want me to take the risk. So this is the biggest risk pharma companies are with which working. And now anything that can save them, they will try to catch hold of it. Now that's the reason now the entire pharma industry, everybody, they are rushing towards AI. So this tells you from a drug discovery, 10,000 compounds. You can see that finally from 10,000 compounds I started with, finally one approved drug comes to the market, which essentially means more than 95% of my investment, the $2.6 billion, 95% of them I am investing on failures. Most of those projects meets the dead ends, and everything meets the red lights. So this is ultimately a problem of prediction. See, from a 10,000 compounds, when you are choosing 250 compounds, what does it mean? You are choosing, you are selecting, you are predicting. You are predicting out of this 10,000 compounds, I am selecting these 250 compounds. So it is a decision-making process. So this is where a good decision will make your project success. This is where we want AI to learn from all the available global knowledge resources which was done in the last 30 years. If you look at the last 30 years within the pharma industry, they have invested more than $1.8 trillion, and the entire $1.8 trillion are right now, which is existing in the form of journal articles, patents, conference abstracts. What if I have a AI engine which can consume the entire knowledge, connect the dots and make sense out of it and take a better decision out of it? I can reduce the cost, I can fail faster, I can fail cheaper. So this is what is right now the task of AI currently, the entire pharma community which is looking at it. So big breakthroughs happen when what is suddenly possible meets what is desperately needed. What I mean by that is big breakthroughs happen. What is suddenly possible? Suddenly possible is this AI. Desperately needed is the solution that the pharma industry is looking for. When these two things meet, obviously the big breakthroughs we can expect. And the company called In Silico Medicine, they developed a new drug for longevity. I mean, they are working on how to make the people to live up to 150 years. So they developed a new drug now. The moment that got published a couple of months ago in Nature, the very next day they got a $37 million investment, additional money. They already got $100 million. So the AI has helped them to attract additional $37 million. This is the reason why the hype is going on. Let me stop, maybe I can stop here with this particular slide. So the evolution of pharma research, we can say that in vivo, in vitro, in silico, this was the past. So the in vivo is testing your chemical with the living animals like mice, or the mouse and things like that. And in vitro is doing the testing in your lab, in your petri dish. And then until recently, we have been doing in silico. We call this as in silico, testing those molecules in the computers. Now I coined a new word, terminology, in machino. In machino is applying AI for predicting the molecules. So this is a 2014 movie Ex Machina, so inspired from that. Now I call this whole drug discovery concept, which goes from in vivo to in vitro to in silico. Now it is in machino drug design. Let me skip all this stuff. So maybe the last two things, just these points. This is, any innovation, the artificial intelligence, at the end of the day, you may appreciate that it has a lot of mathematics, a lot of abstract ideas, but the abstract ideas are not patentable. If you cannot file a patent on your invention, innovation, you cannot protect your invention, which means that you cannot make money out of that. Then why do an investor come and invest money into this? This is a big problem. So all the big patent office directors, they came together, they came up with the new guidelines for accepting the AI patents. So now the AI patents are relatively, as long as there is an applications, it will be acceptable. So look at the kind of a computer vision, natural language processing in the last few years, it is going skyrocketing. Artificial intelligence is a new digital frontier that will have profound impact on the world, transforming the way we live and work. So converting this into money, by 2030, the AI is going to add 15.7 trillion to the global economy. That is more than 4,000 times the cost of one World Trade Center. Do you know what is the GDP of India today? It's less than less than $3 trillion. And China is somewhere close to 12.5 or something. So the $15.7 trillion worth money that will be added, the economy that will be generated through AI, still it has not started. It has not started. We are at the tipping point. From now, the growth is going to grow in the next 10 years. It's combining the India and China's GDP. It's slightly higher than the two GDPs together, today's GDP together. So this is the reason why we are seeing so much hype around AI, and the race for AI has already begun. UK, Germany, and France, they were lagging behind, but their national leaders, they have already announced this year, each country they are going to put $2.5 billion for the next 5 years. And already Trump has announced in the DARPA project, like close to $5 billion in the next 5 years. China, they are already making a big news out of AI. If I go to any of the machine learning AI meetings, 600 people, they present their work, 300 of them, they come from China. So that is what I'm seeing. The huge, big wave which is currently happening. I don't know whether it is partly hyped up also. We need to be a little cautious on that. That also I'm telling. Don't just trust blindly everything. Be cautious. So, and then have a wonderful future on data science and AI. Thank you very much.
Thank you. So my question is on drug discovery part, and let me give you a case example. We were conducting a trial with Mayo and University of Florida almost 3 years ago, and those patients have one particular gene, P53, deleted. Now using AI, we realized that since the gene is deleted, then the drugs which are impacting that pathway will not work. And then we suggested something else, but the drug didn't work. Then there was a paper published in Blood which says that even if a patient has one copy deleted, the P53 expression is high. So these kind of variation which happen at cell or tumor level, how do we sort of incorporate those logics in AI? Because the machine will do whatever you make it to learn, as you given the example 1 + 1 11 or 1 + 1 2.
Yeah, so that's an excellent question. Two things. My focus here, what I presented was more on the small molecule side. There are two things when you talk to drug discovery. One is the biology, other one is the chemistry. I normally say that the biology is $360 million worth identifying any target. And even you take any research institute like this, the investment on life sciences versus chemistry is 1:9. 9 rupees if you are investing in life sciences, chemistry get investment of 1 rupee. This is a global thumb rule. So the same thing works here. The small molecule is a 40. Sorry, I'm not. Last 15 years, I'm not from an academic institute. I talk about this money stuff. So $40 million is worth of a small molecule stuff. And I was focusing more on the $40 million, and your question is on the $360 million. Let me get to this point. there's a Peking University which is working on bringing entire, see, because sometimes even in the journal article, some people will report as upregulation, the whole pathway downregulation in another paper. So which one I should take it? So typically you kind of give a little bit of a scoring over there. So this will all work in a empirical mode. So this is the reason now the systems biology, looking at the holistic approach, the curating all the every individual the journal article into granulating that information into pathways information, the protein expression information, and microarray information, integrating that with the entire proteins. So when you look at the holistically, then that's where you will be able to take a better decision. So this is what the companies like Informatics is working on. And Peking University, you should have a look at it, like how they were able to identify the pathway and then with the use of AI, how they are able to identify the biological target for a given particular disease, taking the decision making through AI for the biological pathway. So it's currently, that's one of the hot area as well. Yeah. What are the variables? What are the variables that I look at? Okay. So the first thing is, I don't get into the variable stuff. There are three different ways how I feed the molecular information into the neural network. The number one is the smile strings. As such, my neural network can understand the smile strings. The second is the one that you are talking about, the descriptors, the property, the variables, the number of columns, multiple columns, 1500 columns. So there again, the issue is which descriptor that I should select. So there, initially the way that we can do is you just pump in everything because it's deep learning. We don't need to be a domain expert. So you know the difference between machine learning and deep learning. If you are doing machine learning, you need to worry about what are the descriptors that I should choose. If you are using deep learning, leave that task to the neural network, let it take which is important, which is not important. It's up to its decision. But the third area, which is only in the last 1 year, which is heating up, is the graph-based theory. Graph-based approach, representing your molecule in a graph-based form, feed it into the neural networks. So that is what is the three different approach. But I would advise, it doesn't matter which approach you take, the much weightage that I would give it to the number of records, number of molecules. That's where my performance of my neural network will be better than the choice of descriptors, choice of variables.
Hello. So I have a very naive question. So what do you think will artificial intelligence will create more like job opportunities in India or actually reduce it? I mean, what is your take on that?
That's a good question. Will AI create more job opportunities? India is a service-based industry. So every time whenever okay, let me put it this way. The difference between US and Europe, from there I will derive an answer for you. In US, new technology comes, US they destroy the existing jobs. So put together, like for instance, they created a new additional jobs of 100 million jobs, but by destroying 30 million jobs, which means they have created, net amount is 70 million new jobs they have created, but in reality they have created 100 million jobs. So I'm just giving an empirical value, whereas Europe is very conservative. They don't just simply jump into it, but when you look at the net jobs that they have created is very less. Now you come to India, we are having a multiple diverse community here. One is the service sector, the other one is the public sector. Some aspects of jobs got destroyed. For instance, we were working for one of the clients on Japanese patents. Our task is to extract the molecular information and biological information from Japanese patents. So the first step is to translate that in English, because none of my employees know Japanese. But the whole business, I mean, I had 30-member team working on that. The entire 30-member team got destroyed because of this natural language processing, which can translate easily the Japanese into English. So that's, then the second thing is Chinese author names, which we need to index it. So I went to Malaysia, I hired Malaysian students, the Chinese, though they can understand Chinese. So those are the jobs which really got destroyed. But new jobs are coming, because on the one hand, these are the routine, anything that can be automatable will be automated. So those jobs are at risk, but new set of jobs are getting created. But actually, if I were, I mean, probably those who are in the early 20s to 30s, they shouldn't worry about it, because they are coming into the job market. But look at the people who are in the 40s. I am close to 50, but still I have to go back and then learn all this stuff from the scratch. So you have to continue to learn, and the job market in this particular field is growing. So last week, Intel is coming to Hyderabad with 1,500 people, new jobs, which is getting created. Google has come to Bangalore for AI stuff, and NVIDIA has a center in Pune and Bangalore, and they are getting into AI. So those new jobs are getting created. Some of the automatable jobs will be destroyed, but the net job created, when you look at it, will be more. Net job that will be created will be more. Obviously, there will be some jobs will be gone, especially when you are in services sector. Because last 15 years I have been in the services sector. So that's the reason, that's why now I am moving into product side after a long time.
Thank you.
Okay, so maybe we can have one or two more questions. If
So, regarding your learning stuff in drug discovery, I think one of the challenges that most of the learning is based on in vivo or the mouse model. But then it is coded in the learning, and then the real drug which is supposed to work on human, that is another failure, because then your logic and learning and everything is based on the in vitro and the mouse model. So do you have any comment on that?
Okay, so my objective personally, I mean, this is, if this question is for a company Vingyani, if you say that, looking from a business perspective, not from a drug discovery perspective. There are several business models which works in the world, in the sense that it is not that I need to have a cure for cancer and then go to the market and make money out of that. If I reach certain milestone, people are willing to buy that for certain amount. Let's say that, and I've just finished my preclinical, probably I can sell the whole output to $1 million. If I move to clinical stage 1, I can sell it for $5 million. When I go to clinical phase 2, then probably I can negotiate for $25 million. When I go to 3, I can negotiate for $100 million, as well as partnering, the profit sharing and things like that. So our company business model ends at preclinical stage. We don't take it to the clinical side. So as far as we are concerned, we are designing new drugs for a given disease, and then we showcase our demonstrated capability to my customers. Hey, why not we together work to design new molecule? I have a platform which can dream for a completely new molecule. Let me give you an example. You know, what is the chemistry space available today? What is the chemistry space available today? 10 power 60. 10 power 60. You know, in a single drop of water, we have a 10 power 23 molecules. 1 gram, whatever, 10 power 23. Let's, for the sake of assume, the whole entire earth, water, the sea water has 10 power 47, but the chemistry space is 10 power 60. And today the FDA approved drugs, the unique molecule is not more than 2000. 2000 compounds, 2000 molecules are the only things that have been approved by FDA, which can be accepted by our human body. But imagine the entire chemistry space. So now I am telling pharma industry, out of this 10 power 60, I suggest you 1000 molecules, unique molecules, which are having a potential to cure cancer. Why not we talk about a business? This is our model. So this is this is not something new. This is our whole practice. And this year, 29 is marked for in the pharma industry, mergers and acquisitions this year. Phenomenal amount of mergers and acquisitions has happened this year. Even you can look at this week chemical engineering news, it's several $1 billion. Why do? They don't have a product in the market. These people are in certain clinical stage, these people are in certain clinical stage. Why not we combine together and minimize the risk? So that business model, that works for them. And we don't know where the cure for cancer comes out of all this business negotiations. So there are multiple things. The whole dynamics is much huge than just linear 1, 2, 3, 4, 5 steps.
All right. One last question. So, does it also help in, apart from analyzing the data and machine learning, does it also help to ask new questions or to ask questions in the gap areas? So you're able
missing
to
data.
Yeah.
Missing data.
Missing data. Yeah.
Missing data.
So does it? Can it also help the funding agencies to make a call in these areas where the information is missing that will help in future?
Can you little bit
so
more?
For example, like in biology, I mean, there's a lot of information available, but it may not be enough for data scientists to come to a meaningful conclusion. So you may come to a certain point, but that may not be enough to say that this drug may be able to treat
I got your
this
question.
disease.
I got the point. So there is something called one-shot learning. I think you should look at it. I mean, the biggest trouble with this entire AI deep learning gamut is that it consumes a lot of data. But in biology, as you said, especially for the pharmacokinetic and pharmacodynamic properties, we do not have the luxury of a lot of data. The deep learning works only well when there is a millions of data. It talks, for them, million is a smaller number. It works well only when there is a millions of data. So there's a lot of work which is going on the one-shot learning. Say, for instance, with the one-shot learning, which means that when I go to a zoo, I see a giraffe. So, I take my kid to, hey, look at this giraffe. So, when next year I take my kid to some other city, some other zoo, immediately my kid says, Dad, look at the giraffe. But I showed him only once that is giraffe, but now with that it got registered in his mind. But AI, you have to show at least 1,000 images of giraffe, so that next time whenever it sees a new picture of giraffe, it identifies that as a giraffe. That luxury we do not have in life sciences. So this is where the one-shot learning and probably some kind of active learning is to fill the gap. Because some data is labeled, some data are not labeled, there are some data which are missing. So this is where which we call it as a semi-supervised learning. There are quite a few of them which are coming in. I mean, they are all converging. Even say, for instance, drug design. We have been talking about generative adversarial networks. We've been talking about variational autoencoders. We have been talking about reinforcement learning. But the $37 million fundraising, that company, they brought all the three together and then they found something new. So likewise, this one-shot learning, transfer learning. Transfer learning is, I learned some new knowledge from one domain. How will I apply that to another domain? So this is called transfer learning. So for instance, I have a neural network which is very well trained in predicting the bioactivity of compounds. But I don't have, their bioactivity compounds, I have millions of compounds. But for pharmacokinetics and pharmacodynamics and toxicity data, I don't have millions of compounds, millions of data points. I have hardly thousands of them. So first I trained the neural network with the bioactivity where I do have a millions of points. With that neural network, I transfer the whole optimization problem into the other project. So that is called transfer learning. So when I combine, holistically look at all these various stuff, I think that should be addressable. I guess people are already working on it to address that kind of an issue.
Right. Thank you very much, Srinivasan. And before we close the session, I request our director to come on the dais and hand over a memento.
Okay, before he gives, I just wanted to disclose one particular point. When I was a PhD student, I mean, till my master's in aerospace, I was an aerospace engineer, by the way, and also I'm a MSc in chemistry, the two sciences. And when I was doing my experimental, I was in experimental work for my master's, I was breaking my head for my PhD problem. And then I was writing whole hypothesis, and one night, probably Professor Umapati may not be aware of it, maybe he would have forgotten. I went to his lab in IISc. I went and discussed with so much of like any motivated student. I went to his lab and then I discussed, this is a problem, and what do you think the spectroscopy I was working on atmospheric chemistry. He was listening the whole story. I was so thrilled that he is going to give some encouraging statements. He said, it's not going to work. No. For 2 days, the next 2 days, I was very dejected. I was a bit upset. I thought he is going to give me a solution, but he said it's not going to work. Actually, after 2 days, I realized it will not work. Good that I got the fail faster is extremely important when you do your PhD. And that's the moment I decided to move into computational stuff. So probably part of the reason that I moved into a data science, I attribute that for Professor Umapati as well. Thank you so much, sir. Thank you so much. Thank you.
Thank you, everyone.